So when you're using intercepts to graph, so let's say we have the equation y equals 2x plus 8. Right, so that's a 2-variable linear equation. It has an x and a y. So in order to do this, we're going to have to find the x and y intercept. So the intercept is where it's going to cross, the x-intercept would be where it crosses the x-axis. Y-intercept would be where it crosses the y-axis. So on a graph, right, remember that we have x, y. So basically what that means is like the x-intercept is where x is equal to 0, right? And then y is where, like when it's the y-intercept, it's going to be where it crosses. So where y is equal to 0. So to find the x-intercept, we're going to plug in 0 for y. I realized that I said that backwards a second ago. Huh? Yeah. Okay. So is this coming back to some of you a little bit? No? Okay. So we're going to plug in 0 for y and solve our equation then for x. So we've got 0, right, equal to 2x plus 8. Oh, what is that? So then we would move the 8 over to the other side. So we get negative 8 equals 2x, then divide by 2. So then our x-intercept would be negative 4. So then to put that on the graph, right, we would go to x equals negative 4. So we're going to go to the left 4, and we're just going to put a dot right there. Right. Then we need to find our y-intercept. So any guesses on how we're going to find the y-intercept? Yeah, we're going to plug 0 in for x. So that means we're going to have y equals 2 times 0 plus 8. So 2 times 0 cancels out is just 0, so that means y is equal to 8. So that means on our graph, let's make that a little bit taller. One, 2, 3, 4, 5, 6, 7, 8. So we're going to go up to 8 and put a dot there, and then to graph our line, we're just going to connect those 2 dots that we drew. Right, so that's how you graph an equation using intercepts. All right, what questions do we have so far? No. Any questions? You feel okay with this? All right. All right, so then if you're following along in this section, we're now on page 161. We're going to talk about how to graph a line when you're given the slope and a point. So remember that slope is rise over run. Right? So that means it's telling you how far up and over, or I guess technically also down and over, that your point's going to move, or how far you move from that point to continue your line. So let's say, for example, we were given the point 0, negative 2, and we were told that the line we needed to draw had a slope of negative 4. So the first thing we would want to do is plot our point of 0, negative 2. I'm going to go ahead and Also, while we're graphing things, I don't want teeny tiny baby graphs that I can't see what you're doing. Make them big enough that I can clearly see the points that you're plotting and where you're moving. So don't give me something like this where you're like, and you like try to cram points on there. Like you make it so tiny that I can't read it, because I will immediately count that wrong. Right? Make them big enough. Okay. So we're going to plot the point 0, -2. So that means we're going down 2 and we're putting a dot right there. Right? So that point's going to be on our y-axis at -2. So then since we have the slope of -4, anytime I have a whole number, I immediately put it over 1. Just so that you remember to like go over instead of just going straight up. Right, so the top number, if it's positive, you go up, negative, you go down. So that means from our green point, we're going to go down 4 and right 1. So from that green point, I'm going to count down 4 spaces. 1, 2, 3, 4. And then over to the right 1. So I'm going to put a dot right there.
You count the space where the dot is on already on the first one?
No, so I start here and then I go next to 1, 2, 3, 4, and then over 1. And put a dot. The other way you can do this is if you have a negative number, right, you can also go up and left. So you either need to be going left or down if you have a negative, but not both. Right, you just have to go like one negative direction. So like from my original green dot, I could also go up 4, so 1, 2, 3, 4, and left 1. Because you can see that's still going to follow my line, right, as I extend it out. So anytime your slope is negative, you can go down and right or up and left. All right, so does that make sense? Right, so then if our slope was positive, that means you would go up and right or down and left. Right, just to kind of okay, what questions do you guys have about this part? Is the slope stuff slowly seeming familiar? Rise, overrun, moving stuff. Okay. Then the last thing I want to go over in this section today is slope-intercept form. So, slope-intercept form is an equation that's written in like a particular way. So that form is y equals mx plus b. So it's basically a two-variable equation that's like solved for y, right? It's y equals. So in this equation, m is, what's lowercase m represent? Slope, right? So that's our slope. And b is our y-intercept.
So then what's the y on the farthest side?
That's just the y for the equation. Like, because remember they have two variables. So you have y equals a number, something x plus b. So, for example, like an equation that looks like this. Right? So from that, we can say that our slope is 3 over 2, and our y-intercept is negative 2. So that means, since we can just look at that equation and, like, pull that number away, like, pull those numbers out, that means using basically the same method we just did a minute ago, we have a point, right? We know the y-intercept is negative 2. So it's right here. Oh, wrong color. Right, so that's like our starting point, and then we can use our slope to move. So that means we can go up 3 and right 2 from our green point. So we can go up 1, 2, 3, and then over 1, 2. We can do it again. We can go up 3 more. 1, 2, 3, and then 1, 2. And then if you, right, then we can connect the points, make a line. Yes. You can tell how really not straight it is when it's a lot bigger, but so does that kind of make sense to you guys? Right, it's basically the same graphing process as before. You just need to be able to look at the equation and pull the numbers. So all right. However, it's too. Can I go ahead and make that smaller, Abby? Okay. It's a little too easy. Oh, I lost. Oh, there's my word slope. If I just give it to you in slope-intercept form, right? So sometimes you have to put it in slope-intercept form before you can like pull the numbers from it. So basically, in that instance, let's say we have the equation x minus 2y equals 4. Nope, sorry. Let's go with 8. Negative 8, actually. So, if you're asked to put this in slope-intercept form, all that's asking you to do is solve it for y. So you just want to get y by itself on the left side. So we're going to move our x over. And you always want like your x in front. So like I'm going to write it as negative 2y equals negative x minus 8. Right, then what else do we need to get rid of? Yep, the negative 2. So we're going to divide everything by negative 2. So then you have y equals a positive 1/2 x, right, because that's negative 1 divided by negative 2. And then negative 8 divided by negative 2 is 4. So it's y equals 1/2 x plus 4.
This is a lot easier after helping to do like quadratic equations and stuff, because now I'm like, oh, that's super easy, but when I first did it, I was like, this is awful.
Yeah. So I feel like you guys learn to appreciate this a lot more by the time we hit it at this point in Algebra 2. So, all right. That's all I wanted to cover out of this section today. Tomorrow we're going to do the rest of it, but you do have an assignment just for the part that we've covered today. And you are going to have to graph some. We just spent like most of the lesson graphing. What do you think we were going to do?